Awesome. Good. Okay. Hi, everybody. They said they wanted to, leave best for last, so here I am. All joking aside, thank you all for coming here at this late hour. Today I'm going to be talking about Schrödinger's NFT. Well, the original title of this presentation was Phala, Moonbeam, and Crust walk into a bar and a crazy cat comes out. But for some reason, they didn't allow me to go with that title. I don't know why. But putting that aside, first I'm going to talk a little about Apillion's mission, which is to accelerate Web3 adoption by continuously empowering its builders. Now, why am I talking about this? It's a nice sentence, but what this means in reality, that we do tons of research on different parachains, different blockchains, different decentralized distributed protocols like IPFS, Arweave, etc. And really go deep into it. We try to break it. All the parachains love our GitHub issues and Discord messages at Saturday evening. Us fiddling around with their chains. But all this goes into creating a full-fledged service for the developer. And one of these services that came out of it, or a example of that research, is Schrödinger's NFT. And I want to talk a bit about first story of getting there. So this came out of research of Phala. So if anyone doesn't know what Phala is a parachain that enables cloud computing or distributed computing. They achieve this through a trusted execution environment. This means that on your home computer, on a CPU, you can, if it has a secure chip inside, you can run code, and the computer doesn't know what it's running. No one knows what it's running there. And because of this, it's a trusted execution environment. And this gives you, good extensions of what you can do in a distributed way. First, these are a few features from the research, and one of the important one is that Phala's, you'll hear this a lot, but Phala has a bit, are peculiar with their naming. So their fat contracts enable access to the internet, which is, really important if you want to do some kind of compute power in a distributed way. And their HTTP requests are currently limited to 16 kilobytes, but this is getting extended to 1 megabyte. So this is, the limitations it has. Then it's written in Rust, all the language everyone is talking about here, since it's a more substrate-based conference. And with their extension Inc. And of course, since this is Phala, they call it Pink. It gives you some encrypted storage. This is also quite important. So this storage is private. No one, it's unseen. It's outside a fat contract. So you can have some private storage, but it's, limited. And you have 4 megabytes of memory when executing the code. And the whole code needs to be executed in less than 10 seconds. These are, current limitations. Another very good thing that it does is that each fat contract gets a private key assigned to it. And this private key is not known to anyone. And since this is only known inside the fat contract, you can do things like private key derivation from it, and that is secure and unknown to others. And you can do things like true randomness because of it as well. And since this is compute power and this is running on some people's computer, you need to pay for it. Of course, it won't be for free. So you have like a cluster of those computers, and you pay for it. Now, these were the foundation from the research that we got from trying to break Phala. And this is the first part of the research. And after this comes, how can we bring it into a full-fledged service? So on this, I'll switch a bit to the actual Schrödinger's NFT demo. So what is Schrödinger's NFT? well, first of all, it's a fancy name our marketing team came up to. But if you go deeper into it, I'll start with a few years back, 3, 4 years back. I was doing an NFT drop for a client, and in that NFT drop, everyone who had the NFT got access to a comic book. So the NFT was associated to the access to the comic book. And how we achieved that back then was, the NFT was on Ethereum chain, metadata was somewhere else. But then, when you actually wanted to read the comic book, you had to first create a signature. With this signature on our backend, we were able to verify who the address that made the signature is. Then we went and did a call to an RPC provider to check if that address really owns an NFT. And if it does, we gave him access to the file. Now, the problem here was that this was all centralized. So the backend that processed the signature, that stored the files, it was our centralized server, even though the NFT was not. So if our server went down, user did not have access to that comic book, and since the NFT is access to the comic book, the NFT itself would become a bit more useless. So when we went through the Phala trusted compute power, this is the first thing that came to my mind. How can we turn that into a fully decentralized, unstoppable application? And result of that is Schrödinger's NFT. So you'll see behind it's powered by Phala, Moonbeam, and Crust. So 3 different parachains to achieve that this dApp and its functionalities are fully unstoppable. So first things first, this page itself is hosted on IPFS, and it's pinned all over the world via Crust network. Second thing, I'm going to connect my wallet here. This will connect to my MetaMask wallet, which is set to Moonbeam network. Here. It will fetch NFT from the Moonbeam network. So this is the second part. NFT itself lives on the Moonbeam network and is by such also fully decentralized. The NFT metadata for this NFT lives also on IPFS, pinned via Crust network. So it's unstoppable that way. So here now we have all the steps that we had before in the comic book use case, but we don't have the compute power. So here is where a FAT contract that we built comes in. So first thing this FAT contract does is it associates a NFT ID with a CID, so a ID of a IPFS file. The second thing is it generates an encryption key that's only known to that FAT contract, and the only way to access, not access the key itself, but use it for encrypting and decrypting is if you own this NFT. So with this, we can upload a file through FAT contract if we have this NFT, and this is verifiable. The FAT contract will encrypt it and store it on IPFS and pin it via Crust. And then if I have this NFT, I can also download it, decrypt it, and I'll get that file. So this will still first ask me for a signature, because the FAT contract verifies this signature, and does an RPC call to Moonbeam to verify I'm the owner of this NFT. And this is the first part. Now I unlock the Schrödinger's box, and a weird snake comes out. We have weird designers, don't mind that. And by pressing the download button, this will now fetch the file, decrypt it, and give it to me. And in this case, this file will be a DID credential. That's just to sparkle a little bit so you can start your creativity of what you can do with this. And I'll go back to the presentation now. So Even though this was the research into the fat contract and its capabilities, we leverage all the different things around it to make this fully, unstoppable. So first thing is storage. So you instead of doing running your own node, IPFS node, Crust network, buying Crust tokens, we all leverage the capabilities Apillon platform already has. So instead of this, we just used our own SDK for simple, upload of the file, and then we leverage that CID with a fat contract. So right now on the Apillon platform, you already have a Web3 storage that has IPFS and IPNS capabilities, pinning via Crust network. It has virtual buckets that work in the same way as S3, so or any other normal storage capabilities. So you can start using it in the same way you have any kind of storage right now. We have API, CLI, SDK, everything to make this simple. So the next step is that the whole page itself is unstoppable because it's hosted through IPFS. We also provide this through our platform. On top of all the functionalities I said before, we give you a reverse proxy in front that can give you an SSL certificate so that your page is served through an HTTPS. You can hook up your own domain to it, and you have a familiar deployment process through an, GitHub Actions. So you make a Git push, everything gets built, pushed to the, through our platform, and it's hosted in an unstoppable manner. Of course, we have all the other, let's say, trinkets with CLI, SDK, and etc. But in reality, you want to do that through GitHub Action and Cloud Functions, or code built on AWS. The third thing there was were NFTs that were hosted on Moonbeam. Now, you can also do that collection directly through the platform. We have a super building wizard, so you don't just think about the collection that you want to do. You make prepare the images, you prepare the metadata, and we take care of everything else. So we have pre-made ERC 721 smart contract for anything you need. So let's say you want to do soul-bound tokens for your ambassadors. So they're soul-bound because a specific person is the ambassador, and you make it revocable. So let's say after 2 years he stops being an ambassador, you can remove or revoke that NFT from him. Or you can do a general collection drop like the usual more one, and you can set your royalties, when the drop will be, what the price will be, etc. And since we have the storage, we also leverage that already. So you can have storage directly on IPFS, and you can deploy this networks on NFTs on A-Star and Moonbeam networks, which are currently supported. And we don't leave you there. We also give you templates made in React, Vue, JavaScript, which makes it really easy to then do a whole UI around it, and when you have the collection and have the smart contract. Now this comes into how we are now transforming this, Schrödinger's NFT, this more or less a demo that we show now, into a full-fledged service. Since fat contracts are written in Rust, we believe that each service that we create is easy to use. It's made for developers that are not Web3 natives. And even if they are Web3 natives, we want to have things simple. That's the reason we make a pre-made Rust contract. So because reality, okay, here there are probably more Rust developers than anywhere else in the world, but otherwise it's not. It's a good low-level language, but it's not that popular for someone doing, app-level things. But we, abstract that complexity by making configurable deployment, and the smart contract or fat contract is already written. So in this case, you'll be able to have, 2 options. Either when you create a collection, you can set the file associated with the NFT as the collection owner, or the owner of the NFT can always upload and download the file and change it. And this is an extension of NFTs, so it will work on any existing NFTs. Currently, we'll support A-Star and Moonbeam networks for this. And as always, we always ship this in a nice dashboard with an API, CLI, SDK, and the full support. And even though this service goes through like we could call ourselves like a centralized proxy, all our underlying results are always fully decentralized. So even the Schrödinger's NFT will be fully decentralized, and you can always either revoke ownership, so no one has ownership of the FAT contract afterwards, or if you want to take it directly to your Phala account, you can transfer that, and it's completely yours. And hopefully that through this talk, you started to think a bit about what you can do with this, with the Schrödinger's NFT and with all the other features. So these are a few use cases that I thought up, except with so not only the comic book use case, but like a real estate. If you have an NFT representing your real estate, you have tons of files, certificates that are associated with it that can just move with the NFT when you sell that real estate. You could do a simple password keeper. So you have your NFT as access or backup for your passwords. And like I hinted a bit before, you can store your credentials or DID or anything else through this as well. Now, I mentioned before there are some limitations to the FAT contracts with the size, so 1 megabyte, etc. So we have some limitations here, but we're always improving, expanding to see what else can we do with this. So I hope this kind of made you think what can be done, what you can use this already for. And you can use this QR code to go directly and register on our platform and already start to tinker with all these features. And another thing I would like to encourage you is to check out our treasury discussion that we have for additional funding of this, which is available on Polkadot forum. Thank you for your time, and I think we have some time for a question or two. Any takers?
Here we go.
As well as storing data, can you do compute power inside the? Can you have like signing contracts with signing data in the private environment? Is it just data access, or can you do things?
No. You can do things. In this case, in the FAT contract, we do quite a bit of things. First is we, check. So we do some compute power by checking the signature and getting the address that created the signature from it. The second thing is we do an RPC call, so an HTTP call, out to the Moonbeam network and check out if that address has any NFTs. And if it has, that's our first check. The second thing is we do have some storage in there, so that ID of the NFT is associated with an ID for the Crust file. So with that ID, we can go then fetch the file on IPFS network, download it, and decrypt it with a key that's stored inside the FAT contract, and then serve that data to the user. So all this is happening inside the FAT contract. And that FAT contract is, distributed, decentralized, saved on Phala blockchain plus trusted execution environment where it runs.
So you could store a private key there, and
Yeah.
and you could have a private key that can move between different people.
Yeah. And what's a good thing is that you can also not only store the private key there, but you can generate it. So it can be generated there in a way that no one has access to it. Only if you have the NFT, you can use it. That's the way we're doing the encryption part. So the encryption key is not known to anyone except the fat contract itself, the code that's running in a trusted execution environment, so no one can access it. That's the beauty of it.
Okay, thank you.
You're welcome.
Thank you for the question. Is there any question from the audience? Any other related to Phala, related to Moonbeam, related to Apillion's work about these NFTs? Okay.
Yeah. In that case, thank you all for listening on this late hour. And if you have any other questions, me and my team are somewhere around here all the time and tomorrow as well. Thank you.